morning. I welcome you all for today's session, A to D converters. So in the previous class we have discussed about the basic classification of electronics like analog and digital communications. So we had an overview about what are all the key sources of analog signal and digital signal, and just what is ADC and what is DEC and what are all the specifications and types of both ADC and DAC. Now in this session we are exclusively going to discuss about A to D converters. A to D converters, it is ADC, which stands for analog to digital converter. It is an electronic device converting an analog signal into a digital signal. So this analog, in this block diagram, you can see an analog input as well as a digital output. In between there is a converter logic which converts your analog signal into digital signal. So this analog block consists of some units which is able to convert this analog signal into digital output, analog input into digital output. Analog signal is nothing but it is a continuous time and continuous amplitude, whereas digital output is nothing but your discrete amplitude and discrete time. So your continuous time and continuous amplitude in the input given is converted into discrete time and discrete amplitude in our output. This is the function of ADC. Why we are going for this ADC? In our real world, every real quantity such as voice, temperature, weight, etc. exists in the analog state. But our device like computer or our cell phone, we are using our mobile phones, right? So these devices cannot accept these parameters like directly voice, temperature, weight, etc. which are all in analog state. So there is a need of a conversion to accept that is said to be as digital. So these devices can accept only the version of digital like binary forms, zeros and ones. So this is the need why we are converting analog signal into digital signal. So you can see the block diagram of ADC. So this is the block diagram of analog to digital converter, whereas your analog input signal is continuous in time and continuous in amplitude, and your digital output is discrete in time and discrete in amplitude in a binary form. This is your input and this is your output. In between you have some process, ADC process, with some blocks, that is some units like sample, hold, quantize and encoder. These four are the main blocks. Like sample, where it is used to sample the input signal, whereas the sample amplitude is maintained and held in the hold block. It is an analog value. The hold sample is quantized into discrete value by the quantize block, and finally the encoder converts the discrete amplitude into the binary form. So in general we had a discussion about each block. Now in detail let us know the function of each block. First one, sample. Sample, the input signal, it samples the input signal at a specific time interval. That samples are taken in continuous amplitude and possess real value, but they are discrete with respect to time. So this sampling frequency plays an important role in the conversion, which is maintained at a specific rate. The sampling rate is set according to the requirement of the system. So the next block is hold, whereas it has no function, it just holds the amplitude, sample amplitudes until the next sample is taken. None of the function here except it value, the hold value remains unchanged till the next samples. And next block is quantize. This block is used for quantization. It converts the analog or continuous amplitude into a discrete amplitude. So the signal is now in digital form as it has discrete time and discrete amplitude. Okay. So this is the fourth block, and last our fifth block is encoder, whereas this encoder block converts the digital signal into binary form, that is into bits. We know very well what is a bit, what is a byte. 8 bits form a byte, and this byte form a flip-flop from a registers. As we know that the digital devices operate on binary signals, it is necessary to convert the digital signal into a binary form. using the encoder. This is the whole process of converting an analog signal into a digital form. Thank you.